Hello students, once again welcome back to the class of Ravi sir, the easier and better way to learn the concepts of mathematics from standard 9 to 12th, including JEE Maths and Advanced Mathematics. Students, in our today's video lecture we are going to learn applications of LCM and HCFs. Students, in our previous video lecture we have learned almost everything regarding real number. In this video lecture, students, we will learn in which cases, in which queries we will find out LCM and HCFs. Okay students, here you can see that applications of LCM and HCF. Now there are various real life applications of LCM and HCF. The best way to understand these graphs, the concepts of LCM and HCF, is to learn via example. So let us take a look few example which will help you understand LCM and HCF. Students, HCF, where we need to split things into smaller sections, to quality distribute more sets of item into their larging groups, to figure out how many peoples we can invite, to arrange something into row or groups. When you can find out LCM? About an event that is or will be repeating over and over. Second, to purchase or more, get multiple items in order, have enough. To figure out when something will happen again and again. Students, here it has been clear that when you will have to find out LCM and HCF of any queries, I am giving few shortcut tips from which you can determine in these queries you will have to find out LCM and HCF. Okay students, whenever there is word like a highest, maximum, occupied, more, largest, tallest, whenever you are getting these kinds of word, just find out HCF. Okay, when you getting least, smallest, minimum, at least, just find out LCM in that queries. Okay students, if you are new to this channel, just subscribe and don't forget to press the bell icon. Okay students, let us start the first question. In very first question, students, find the greatest number of 6 digit exactly divisible by 24, 15 and 36. Here is not S. So let us see the solution of this query, student. The greatest number of 6 digit, 9,99,999. First we need to find out LCM, because so LCM of 24, 15 and 36. Then divide 6 digits number 9,99,999 by LCM and subtract the remainder from 6 digits from number 9,99,999. So first of all students, we will get the prime factorizations of 24, 15 and 36. Here many students, you can see that the prime factorization of 24 is 2 into 2 into 2 into 3, 15, 3 into 5, 36, 2 into 2 into 3. So LCM of these numbers will be 360. Okay students, now 9,99,999 will be divided by 360. So we are getting quotient 2777 and the remainder will be 279. Therefore the remainder is 279. Hence the required number is 9,99,999 minus 279. So we are getting what? 9,99,722. Hence 9,99,720 is the greatest number of 6 digit exactly divisible by 24, 15 and 36. Students, in these questions, just you will have to find out LCM of 24, 15 and 36, and that by that LCM you will have to divide the the greatest number of 6 digits, you are getting what? Remainder is 279. Just 279 should be removed from 9,99,999. So you are getting 99,09,072, which is your required result. Okay students, now moving to the next question. Question number 2. Find the least number that is divisible by all the number between 1 and 10. Okay student, here the word list, it means you will have to find out LCM numbers between 1 and 10. So numbers between 1 and 10 are what? 2, 3, 4, 5, 6, 7, 8, 9. So you will have to do the prime factorization of 2 to 9 and get the LCMs. That will be your required result. Okay students, let us see the solution of this question. 1, the factorization of 1 is 1, 2, 2 into 1, 3, 3 into 1, 4, 2 into 2, 5, 5 into 1, 6 can be factorized as 2 into 3, 7 can be factorized as 7 into 1, 8 can be factorized as 2 into 2 into 2, 9, 3 into 3, and 10, 2 into 5. So LCM of these numbers student, 2 into 2 into 2 into 3 into 3 into 5. So we are getting what? 2520. Hence the least number divisible by all the numbers from 1 to 10 is 2520. Okay student, let us repeat all these things once again. Here students, the numbers are given 1 to 10. So here you will have to find out least number. So earlier I have told you that whenever there is a least number, so find out LCM. So we will find the LCM between 1 to 10, right? So what the numbers which occurs between 1 to 10, the numbers will be 2, 3, 4, 5, 6, 9, 6, 8 and 9. So student, we will get the factorization of these numbers in such that we will get the LCMs of these factors, of these integers. So the LCM we are getting 2520, which is the least number divisible by all the numbers from 1 to 10. So the number is 2520. Okay students, just write down this question in your notebook. Now we are moving to the question number 3 student. The question number 3 states that what is the smallest number that when divided by 35, 56 and 91 leaves remainder of 7 in each cases. So student, here you can see that you will have to find the smallest number. So I have told you that when you want to find out least, smallest, minimum, just find out LCM. So students, here we will find out the LCM of 35, 56 and 91. So first of all, we will do the prime factorization of 35, which is 5 into 7. Prime factorization of 56, 2 into 2 into 7. 91, 7 into 13. So LCM of 35, 56 and 91 will be 3640. So the smallest number when that divided by 35, 56, 91 leaves remainder 7 is 3640 in each case. Okay student, just repeat once again. In this question, students, you will have to find out the smallest number which is divisible by 35, 56 and 91. That smallest number when divided by 35, 56 and 91, in each case every time it gives remainder 7. So students, we will find out LCM of these numbers, means LCM of 35, 56 and 91. So students, first of all do the prime factorization of 35. The prime factorization of 35 is 5 into 7, and the prime factorization of 56 is 2 into 2 into 2 into 7. Prime factorization 91, 7 into 13. So the LCM of 35, 56, 91 will be 3640. So the smallest number that when divided by 35, 56, 91 is what? 3647 by adding 7. Okay students. Now moving to the question number 4. In question number 4, you will have to determine the number nearest to 1,10,000 but greater than 1 lakh, which is exactly divisible by each of 8, 15 and 21. So let us see the solution. The number which is divisible by 8, 15 and 21 is also divisible by LCM of the number. The LCM of 8, 15 and 21. So we will do the prime factorization of 8, 2 into 2 into 2, 15, 3 into 5, and prime factorization of 21, 2 into 7. So LCM of 8, 15 and 21 will be 840. Okay, if we divide 1,10,000 by 840, we will find out that it is not exactly divisible, and we are getting 800 as a remainder. Thus nearest to 1,10,000 but greater than 1 lakh, which is exactly divisible by 840 and also divisible by 8, 15 and 21. So students, 1,10,000 minus 480 is equal to 1,09,020. Hence 1,09,020 is exactly divisible by 8, 15 and 21. Okay, let us see once again. Here in this question, students, determine the nearest. Again, nearest means it is similar to smallest, minimum. Okay, whenever these kinds of word, you will have to find out LCM. So here student, the data is given that the nearest to 1,10,000 but greater than 1 lakh, which is exactly divisible by each of 18, 8, 15 and 21. So the students, the number which is divisible by 8, 15 and 21 is also divided by LCM of the number. So LCM of number 8, 15 and 21. So do the prime factorization of 8. So prime factorization of 8 is 2 into 2 into 2. Prime factorization of 15, 3 into 5. Prime factorization of 21, 3 into 7. So LCM of 8, 15 and 21 will be 840. Okay, if you divide 1,11,000 by 840, it is not exactly divisible. It means you are not getting the remainder 0. So finally that number will be subtracted from 1,10,000 and you will get 1,09,020. Okay student, now moving to the question number 5 over here. In question number 5, you can see that you will have to find the smallest number which leaves remainder 8, 12 when divided by 28 and 32 respectively. Okay students, let us see the solution. It is given that the smallest number when divided by 28 and 32 leaves remainder 8 and 12 respectively. It means 28 minus 8 20 and 32 minus 12 20 are divisible by required number. So therefore the required number is 20 less than the LCM of 28 and 32. So first of all we will do the prime factorization of 28. So prime factorization of 28 is 2 into 2 into 7, and the prime factorization of 32 2 into 2 into 2 into 2. So LCM of 28 and 32 students, here we are getting what? 224, right? So 224 is such a number which is divisible by 28 and 32. If you divide 224 by 28, you will get remainder 8, and if you divide 224, you will get remainder 32. Okay students, let us repeat once again. Here in these questions, find the smallest. It means students, in this question you will have to find out LCM. Okay, so when the smallest number divisible by 28 and 32, you are getting remainder 8 and 12. That is smallest number you will have to find out. Okay students, from the given solution you can see that the prime factorization of 28 is 2 into 2 into 7, and the prime factorization of 32 is 2 into 2 into 2 into 2, right? So we will find out LCM. So how you can find out LCM? First of all, write down the pair numbers and then write down non-pair numbers, and getting the multiplication of these numbers we can find out LCM. So finally we are getting what? The LCM is 224, which is divisible by 28 and 32 and gives the remainder 8 and 12. Okay question students, moving to the question number 6. The question number 6 states that find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. So students, let us see the solution of this problem. Which are the given number? 520 and 468. So the smallest number you will have to find out students, which is increased by 17, is exactly divisible by 520 and 468. It means students, we will find out that number and that number will be subtracted. You will subtract 17 from that number, you will get your final result. So students, here you will have to find out the smallest number, means obviously you are going to find out the LCM of 520 and 468. So whenever you are finding the LCM of any numbers, so write down the prime factorization of that number. So prime factorization of that number is 520 is 2 into 2 into 5 into 13, and prime factorization of 468 2 into 2 into 3 into 3 into 13. So LCM of these numbers will be 4680. So a smallest number which when increased by 70 means exactly divisible by both 520 and 468. So 4680 minus 70, so 4663. It means student 4663 is such a number when you divide 520 divide with 520 and 468, it will be increased by 70. Okay students, let us do the quick revision. What you have to do over here, just find out LCM of 520 and 468. You know how to do the prime factorizations of any integers. So find out prime factorization of 520 and prime factorization of 468. Then find out LCM. So first of all, write down the paired elements and then write down the non-paired elements. All these numbers will be multiplied. So you are getting LCM of 520 and 468, 4680. Right student? Okay, so smallest number you will have to find over here. when you can find out smallest number, when 17 is here, 17 is increased, it means remove the 17 from 460 4680, you will get what? 4663. Okay students, now moving to the question number 7. In question number 7, student, find the LCM the LCM and HCF of two numbers are 180 and 6 respectively. If one number is 30, then you will have to find out other number. Okay student, I think you have studied the relation between LCM and HCF. Students, we know that from the data it is given that LCM is 180 and HCF is 60. First number is 30 and you will have to find out second number. Means second number is unknown. Consider the second number is x. Okay student, we know the relations between LCM and HCF. So LCM into HCF is equal to product of two numbers. Okay students, so LCM into HCF is equal to first number into second number. LCM is given, the LCM is 180 and HCF is 6 and first number is 30. You will have to find out x. So what will be x? 1080 divided by 30, you are getting what? 36. Okay students, let us repeat once again. Here in this question, the datas are given. What are the datas? LCM and HCF are given, right? And one number is given, you will have to find out other number. Student, we know the relation of LCM and HCF. We know that LCM into HCF is equal to product of two numbers. Suppose you want to find out LCM of AB and HCF of AB. So if you are getting the multiplication of LCM of A and B and HCF of A and B, that will be equal to A into B. Similarly students, this statement can be written as over here. LCM into HCF is equal to first number into second number. So according to the data, the LCM is 180, HCF is 6, first number is 30 and second number is x. Now you will substitute the value of LCM and HCF. So what is LCM student? 180. What is HCF? 6. What is the first number? 30. What is second number? That you have to find out. So 180 into 6 is equal to 30 into x. So 180 multiplying by 60, you are getting 1080 is equal to 30 into x. So divide by 30, you are getting second number 36. Okay students, now moving to the question number 8 over here. The question number 8 states that the HCF of two number is 16 and their product is 3072. So find their LCM. Student, we know that HCF of two number is equal to HCF of two number is what? 16 and their product is 3072. Now students, we know that LCM into HCF is equal to product of numbers. So from the given data student, HCF is 16 and their product of number is 3072. So unknown value you will have to find out LCM. So what will be the LCM? 3072 divided by 16. If you will divide 3072 by 16, you will get what? 192. It means student, the LCM of two number will be 192. Sorry, find out LCM. So LCM of two number will be 435. Here is been students, you can see that you will have to just make the correction of these data. So 3072 divided by 16, you can correct it, it will be 435, not 192. Okay students, this is a printing mistake. Okay, let us see once again. The HCF of two number is 16 and product is 3072. So here we have to find out LCM. HCF of two number is 16 and their product is 3072. We know that LCM into HCF is equal to product of two numbers. LCM into HCF is equal to product of two numbers. So LCM into, now put the value of HCF, the value of HCF is 16, is equal to 3072. Okay students, now here your target is to be what? Find out the value of LCM of two numbers. So LCM of two number is equal to 3072 divided by 16. So finally you are getting 435. Here it is printing mistake, just make it correct student. Okay students, now moving to the question number 9 over here. It is bit smaller because due to typing due to less space, just make it zoom little bit. Okay student, in question number 9, HCF of two number is 145 and their LCM is 2175. If one number is 725, find the other number. Okay student, this is similar to the question number 7. Students, we know the relation between HCF and LCM of two number A and B. Product of two number is equal to HCF into LCM. According to the given datas, HCF is 145, LCM is 2175. One number A is 725, other number B unknown. Students, our target is to be what? Find out other number. So B will be equal to HCF into LCM divided by A. So value of HCF 145 and the value of LCM 2175, which will be divisible by divided by 725. If you are dividing these numbers with 725, so 725 will be cancelled out due to factoring 2175. So finally we are getting 145 into 3. So 145 multiplied by 3, 435. Therefore the second number is 435. Let us see students, repeat once again. Here HCF of two number is 145 and the LCM is 2175. One number is given, one number is 725. So we will have to find out other number. Here students, we know the relationship between LCM and HCF. We know that if we want to find out LCM of HCF of any two integer A and B, so LCM of A and B into HCF of A and B is equal to A into B. Means product of two number is equal to product of LCM and HCF. Students, according to the data, the value of HCF is 145 and the value of LCM is 2175. So students, finally you can eliminate B. By eliminating B, you can find your result 435. Okay students, now we are moving to the question number 10. Here you will have to answer this question yes or no with justification. Can two number have a 16 as their HCF, 380 and their LCM? Give reason. So students, your answer will be no. Two numbers does not have a 16 as their HCF and 380 as their LCM. Okay students, let us see these things step by step. No, 2 number does not have 16 as their HCF, 380 and their LCM, because we know that HCF of 2 numbers is always factor of their LCM. Hence 2 number have a 16 as their HCF and 380 as their LCM is not possible. Students, just repeat once again. In this question you will have to justify that can 2 number have 16 as their HCF and 380 as their LCM? If it is yes, so why? If it is no, so why? So students, the answer of this question is no. 2 numbers does not have 16 as their HCF and 380 as their LCM. Because students, we know that HCF of 2 number is always factor of LCM. What is your reason for justification of this question? LCM of 2 number is always a factor of LCM. You will have to note it down, this statement. HCF of 2 number is always a factor of their LCM. Hence you can conclude that 2 number having 16 as their HCF and 380 as their LCM, it is not possible. Okay students, now moving to the question number 11 over here. In question number 11, a rectangular courtyard is 18 meter and 17 centimeter long and 13 meter 27 meter broad. It is to be paved with square tiles of same size. Find the least possible numbers of each tiles. So students, the age of rectangular courtyards is 18 meter 72 centimeters. So we can write 18 meter plus 72 centimeter, and 13 meter 20 centimeter means 13 meter plus 20 centimeter. On taking out HCF of 1872 and 1320 using Euclid division lemma. So students, we know that Euclid division lemma, A is equal to BQ plus R. So A is always greater than B. So A will be 1872 and B will be 1320. 1320 we will divide 1320 to 1872. It goes one time. So we are continuing this process by a long division method till that step, until we are not getting the remainder 0. We will have to do all this process till we get remainder 0. So previous remainder accepting to the 0 will be HCF of 2 digit to find HCF using Euclid division lemma. So students, here we are getting HCF as a 24, right? So the number of required tiles. So we will divide the area of courtyard with the area of tiles. So area of courtyard like a rectangular. So area of rectangle is L into B, and area of tiles is like a square. So area of square is side square. So by taking the fraction of area of courtyard and area of tiles, we are getting the number of tiles is 4290. Okay students, let us repeat once again. In this question, the size of courtyard is given. We have to find out how many tiles can be possible we can put into 30 yards. So first of all, our target is to find out the HCF of 18 meter 72 centimeter and 13 meter 27 meter board 30 yard. So we will find out HCF of these two integers by Euclid division lemma, and then we will take the fraction of area of 30 yard and area of tiles to get the required result. Okay students, now moving to the question number 12. In question number 12, in a morning walk, 3 persons step off together. Their steps measure 18 centimeter, 85 centimeter and 19 centimeter respectively. What is the minimum distance it should work so that we can cover the distance in complete steps? Students, here you will have to find out minimum distance. Okay, whenever you will have to find out minimum, least, nearest, lowest, slowest, when you are getting these kinds of word in any query, just find out LCM. So students, we will do the prime factorization of 80. The prime factorization of 80 is 2 into 2 into 2 into 5, and the prime factorization of 85, 5 into 17. Prime factorization of 90, 2 into 3 into 3 into 5. So taking the LCM of 80, 85 and 90. Students, by taking the LCM of these integers, we are getting the LCM 12,240. So minimum distance each should walk so that can cover the distance complete step is 12,240 centimeter. So students, this is a very big data in centimeter units. So 12,240 will be divided by 100 to convert these unit into meter. So finally we are getting what? 122 meters. So students, so our result is what? In a morning walk, 3 persons step off together. Their steps measure 80 centimeter, 85, 90 centimeter respectively. So 122.4 meter is the minimum distance it should be work so that he can cover the distance in complete steps. Okay students, I hope you have understood these questions, solution of these questions. Nothing you will have to do over here. You will have to just pick the important word minimum. It means you will have to find out LCM of this data, and that data should be converted into meter to get our desired result. Okay students, now moving to the final touch of this video lesson. In this question, a circular field has a circumference of 380 kilometers. 3 cyclists start together and can cycle 48, 60 and 72 kilometers a day around the field. When will they meet again? First of all students, we will get how much time all 3 cyclists take to cover a circumference of 360 kilometers. So students, the time taken for the cyclist first, 360 by 48. So he takes 7.5 days. Similarly, second takes 6 days, and third number cyclist take 5 days. Here students, you will have to find out LCM. So finding the LCM of 7.5, 6 and 5, we are getting LCM as 30. So they will meet after 30 days. So we can find out how many times they have covered the circular path. Okay, in 30 days, first cyclist will travel 30 divided by 7.5, 4 rounds. In 30 days, second cyclist will travel 30 divided by 6, 5 rounds. In 30 days, third cyclist will travel 30 divided by 5, 6 rounds. So after 30 days, all 3 cyclists will meet at a starting points. Students, this is a very easy questions. What you have to do over here, the total distance they have to cover 360. All the cyclists having different speed. So we can conclude how much time it takes by each cyclist to take the round in such that they will meet once again at a same point. So students, here the first cyclist travel circular path 7.5 days, and second cyclist takes 6 days, and third cyclist takes 5 days. So we will take the LCM of these days. So finally we are getting 30 days. It means students, after 30 days all the cyclists will meet at starting points. Hope students you have understood this video lecture. Thank you so much for watching this video lesson. Okay.